Hey there, folks. Welcome to Learn Live.
I can't get enough of the music, Jason.
I could see that. You were
DJ Laurent, you're a genius. That's what I want to say.
love that publicly available music. Actually, I don't know if it's publicly available music or not. For all I know, we composed it ourselves. So welcome to Learn Live, everyone, and welcome to our Azure Well-Architected Framework session. I'm Jason DeBoover. I'm going to be one of your hosts for our little shindig today. And David Blake Edelman, you are our other host.
Hello.
So, folks, like all of our Learn Live sessions, you're able to follow along with us, or you could always follow along afterwards if you find our video so compelling that you just can't tear your eyes away from it. You could actually go and follow along later. But if you want to follow along with us, see the Learn module that we're going through, even as we go through it, you can do that by visiting the Learn module itself. And we've even got a nice little QR code to make that easy. You could scan that in and pop right over to the link. Isn't that right, David?
I'm thrilled. I have never seen a better QR code in one of these things before. I hope people are appreciating them.
So, by the way, we've got a lot of Learn Live sessions, so this isn't the only one. Learn Live is chock full of goodness. My slides aren't advancing. That's fun. Okay. Let's see if I can.
This will be an excellent slide for 90 minutes.
Gosh,
Jason.
why? There we go. We're starting to get some advancement from the slide now. Fun times. Yeah, we'll just talk through. We'll just show one slide the entire time. Just keep talking through it. I'm sure nobody will be bothered by that, right? So let's actually do a quick introduction of ourselves while folks are catching up with the links that we're showing them. And I'm Jason DeBoover, as I mentioned. I am a program manager on our Docs, Learn, Architecture Center content team. So I'm one of the folks who helps to figure out what's going to be the most meaningful content to create for you all when it comes to our Docs platforms, our Learn modules, our training modules, all of that good stuff. I hope that we're doing a good job of creating exactly the content you need. But if we're not, we're here to try to continue to improve. So feel free to give us that feedback too. David, tell us a little bit about yourself.
Hello, I'm a Virgo. I like long walks on the beach, or more explicitly.
That's exactly what we needed to know today. Thank you.
No. Well, I mean, some of that's true. Anyway, I'm a senior cloud advocate here at Microsoft. I spend a lot of time paying attention to things like site reliability engineering and other modern operations practices, which is why I love this particular topic. I'm psyched to be talking about how to make your services and your apps better and what questions to ask about them. So I think this is gonna rock. I think it's gonna be really good.
Absolutely. And this is live, which means y'all have the chance to talk to us. In fact, in a sense, this is a deja vu all over again for David and I. We have given this actual session before, but here we are live again. And why is that? Because when we're live, we get to interact with you. We get to talk with you. We get to figure out what matters to you, hear it, react to it, and have a little conversation.
Yeah. And I want to say, when you get to the learning objectives, I want to be clear that, like, this says describe the pillars of Azure Well-Architected Framework so that you can describe it to other people or identify key principles for creating a solid architectural foundation. Another objective that I think we have for this session is we're not here to read the module to you, like to read it out. It isn't like the audiobooks version of Microsoft Learn, right? This is meant to be where we're going to say stuff that's not in the module. We're going to put some color commentary on it. We're going to ask you some questions. We're going to hopefully question your answers and answer your questions. And we're kind of here to really interact with this sort of stuff and talk about stuff that you're interested in and give our perspective, having been in this biz for quite some time. So.
Hey, random plug. If you were interested in the actual audiobook version of any of the written content we have, Microsoft has this amazing thing called Immersive Reader that will help you with that.
Cool. I'll look forward to that later.
Random plug, since he decided to say that.
No, I'm totally down with it. Okay, well, let's do stuff.
Let's do stuff. All right, introduction again. Go ahead, do your voice.
Oh, I don't know why I get forced into this, but fine. The Azure Well-Architected Framework will help you to design, build, and continuously improve a secure, reliable, and efficient application. So as you can probably tell, we're going to go through this with a little bit of humor because we will probably poke fun at our own slides and our own documentation, but it's all in good. It's all in good humor. You know, we're trying to really just we enjoy this stuff, and we're hoping that that comes through. So
yeah, make no mistake. We take this stuff very seriously. In fact, it is absolutely vital to your applications. But yep, when we're having a meeting, when we're on camera, when we're talking to each other, even it's time to have a little bit of fun with it, but to make sure we still get the job done, right?
Yeah.
And the way we do that with our framework, with our well-architected framework, we focus first on making sure that we're thinking in terms of these top level pillars.
Yeah, and so I don't know why that's a balloon with a box attached to it, but it's basically saying that, you know, a bunch of stuff has changed when it came to like trying to run stuff both on-prem and this says in the cloud. But I want to be clear that the stuff that we're going to talk about here is equally applicable if your stuff is on-prem or if it's in the cloud or you have a combination of the two. But it made us start to think about things in a particular way, and I think that's where you get this sort of the cloud, and I think that's a seagull, but I'm not entirely certain.
And to be sure, we call it the Azure Well-Architected Framework. So to some extent, there's a little bit of a there's that little bit of a bias to talking about cloud concepts. But you know, as David says, you know, look, reliability, security, these are our pillars. These things absolutely apply. They're the things we need to consider when we're developing an application, when we're designing a system of any sort, when we're hosting a system of any sort.
Yeah, and as an operations professional, one of the things I really want to say about the term Azure Well-Architected Framework, which I know that threw me off when I first started hearing about it, was this notion that like, oh, architected. Well, let's see, I go get an architect for my house, and we figure out what we're going to build in the house, and we build the house. You're not used to like sort of like an architect knocking on your door and saying, hey, let's architect some more. But it turns out that the well-architected framework is about how to stay in that well-architected place, you know, and that's the goal here. And to do that, we're going to be thinking about these pillars. These are the particular pillars we think are get you to ask the right questions when not only are you building it for the first time, but when you're trying to run it, or when you're trying to iterate your solution, or you're trying to even towards the end of its life cycle, when you're trying to figure out what to do. And so that's why we think these pillars stand, no pun intended, like all throughout the software life cycle. So
I think you bring up an interesting point about architecting being this is it this thing that happens at the beginning and then you throw it over the wall and it's done versus that iterative process, and I think that's we need to think about that in terms of the metaphor for engineering of software and software systems overall. Right, because we hear that a lot about how, when you build a bridge or you build a car, you have to have everything planned perfectly up front. You have to know what you're building. I mean, sure, you get some opportunity to go to the test track, but but you have to be pretty sure about what you're building before you go into production. And we have, of course, learned over time that that's not the optimal way to develop software systems. We do want to provide some functionality and iterate, some functionality and iterate. And I think, that applies actually to these pillars too. We want to know how our users feel about aspects of reliability and iterate. If we're over servicing on certain things, maybe we have a chance to pull that cost optimization down. Whereas if there are things that are problems for our users, we have a chance to iterate. We can improve on, say, our performance, or we can improve on how we're delivering the ancillary services.
Well, it's interesting you say that because somebody in the chat, Michael Patton, was saying, when applicable, please speak to any trade-offs that come from discussing the Azure framework. I want to be clear that this thing is like lousy with trade-offs, right? Like
all we talk about the rest of this
because I mean, you get into these situations, and Michael, I really appreciate you bringing this up, because you get into these really situations where you're like, oh, well, let's see, it might cost more if we want to make it more reliable, or, security, what about security and how we're going to do our, is that going to get in the way of our operational excellence? There's lots of places where this goes. So I promise you we'll talk a lot about trade-offs here. Now, if you want to talk about talking about trade-offs, which may be what your question was, and feel free to clarify if we're not quite getting it, then, just discussing it. Like, I don't think there's a problem with discussing it. I think that you probably won't get into any fistfights when you say reliability is important. But you have to be willing to hear the pushback that comes in these discussions, because they're going to say, but there are trade-offs. So I think that's really cool. Okay, I think we should talk about general design principles, mostly because you switched to that slide.
I mean, I can switch back. You know,
No, I'm good. I'm good. Let's do it.
You're
Let's
the
do it. I
boss.
thought no. I insist. Go ahead.
Let's talk about the general design principles. Please begin, sir.
Okay. Well, so the basic idea is that there's there's some general design principles that tend to take into account all these pillars, right? The first one is this notion, as exactly what Jason was talking about before, that you would expect some sort of evolution in your software, and you can make it harder to have evolution in your software, or you can make it easier. And so when you're doing this, you really want to do what you can to make sure you can enable it so that you're not like stuck in the 1800s with your software, and you're shoveling coal into the machine. You're like, gosh, I only wish we could use electricity. That would make our life so much better for our apps. Second of all, I think in our list is we want to make sure that when you're doing that, you're not like scratching and going, like, I think things are reliable. Do you think they're reliable, Jason? No, Jason says, yeah, they're really reliable. And instead, you want to use some real data.
It feels reliable.
Yeah, my gut says that we're really reliable. Like that's like run is if someone says that to you. Educate and enable, that's true about everything in your life. So I don't think there's anybody would argue with that. And automate, this is one of these things where like let the humans do what humans are good at and let the machines do what they're good at. And the more you can automate things and get rid of toil, which is something that shows up in my world in site reliability engineering, sometimes the better you are. And we'll talk about that stuff. I promise that'll come up again in operational excellence.
Yeah, I want to zoom in again on enable architecture evolution and use data to make decisions and talk again about iterative processes. We need data to do better, and the only way to do that is kind of I sort of hate to say it this way, but throw something against the wall and see if it sticks. Right? We have to start with some small core of functionality, so the core of what we need and what we want, and see what needs to improve. And that's that by having an application, by having a core, then we can start to gather data, and then we can continue to iterate and improve. Now, there are certain things that we better need to know up front, like what are our security exposures. So we'll talk more about that in a little while. So there are definitely some things that we need to consider, but we can start, for instance, with a very small surface area in terms of our security to make sure that we don't have to hire a 300-person team in order to secure it. Let's keep a small surface area so that we can continue with our ideals of starting small and iterating to make good decisions.
Yeah, and like it's also pretty obvious to say. I think I'm not quite sure this is a John Cage quote, but he was basically at one point in time he said something along the lines of, are things getting better or are they getting worse? Right? And like if you don't have data, you don't know that. And did you make a change? Don't know. Okay, but I feel I'm hungry for the first pillar. Oh no, you want to do this?
Patience, my friend. Patience.
Oh yeah. Okay, I'm cool with that. Fine. I was looking at the wrong slide. I'm down with that. Okay, so the thing to understand here about what once upon a time we used to call the shared responsibility, and I just can't stand that because I think it's not that we both do the same thing and we share it in that way. It's more like there are two parts to the responsibility that goes on to moving something into the cloud, right? And part of that just basically says some of it is on us, Microsoft as the cloud provider, to provide the resources to build our things right, to make sure that we give you the handles and the information you need to make sure that we're building what people need. And on the other hand, there's also this notion that says like, hey, if your app code is terrible, it's on you to figure out like why is your app running slowly if it's been written in an inefficient way, or if it has a single point of failure, it might be up to you to architect things in a way that and there comes the well-architected, in a way where your app is doing the right thing from that perspective, because we can only do so much and you can only do so much, and that's why it's kind of between the two of us. And that's why there shows like this nice box that shows it's between the people that are writing the apps and the people that are providing the platforms that they're running the apps on, i.e. us, to do the right thing. So
let's do a quick definition for the folks who might not be familiar with this view of what we've got. So on-premise is maybe obvious, but who knows? It's when you're running your own data center. It's when
there's my server right over there. My server's right there.
Yeah. Or I don't know. I hope it's at least in a data center that happens to be yours, not literally below your.
That's my data center.
What's that?
That's my data center. I don't know what your problem is. It's in my living room. I don't know what the problem is. Yeah.
I'm sure the fire suppression system is on point. So that's when you're running your own server, right?
Right.
That's when you're running your own network. That's when you're running your own everything. As I said, the fire suppression system, that's on you. Data replication, offsite storage, that's on you, right? All of that stuff. Infrastructure as a service, that's your I and IaaS there. Our infrastructure as a service is when we've literally just kind of what they call lift and shift. We've taken the same operational principles and put them onto some virtual machines that Microsoft is running for you. So more or less that's it. There's kind of a middle ground, I like to think, between IaaS and platform as a service. Now, I kind of put in my mind things like Kubernetes right in between those two. I don't know how you feel about that, David.
Well, I think Kubernetes is sort of like an orchestrator. I mean, but it's not. I mean, it's not that terrible. It's pretty close. I mean, I think it's closer to a platform than it is to IaaS. I mean, I think of IaaS as congratulations. Instead of you buying machines or bunch of servers, we're buying the servers, and you just happen to be running on our servers, right? And it doesn't mean that it means that you're taking care of things like the updates on them. You're taking care of the operating system updates. You're doing some of the basic lower level stuff. You've decided to take that on because you have a good reason to do so, as opposed to platform as a service where we're like, okay, cool. How about if we take care of that and we just provide to you something that allows you to build on a larger service, so you don't have to worry about like, is this on 3 machines? Is it on 5 machines? Do I not have enough machines? Like, we'll build the platform and give that to you.
Yeah, and I think so. I guess just going back to my point real quick with Kubernetes and containers, we do sometimes have to worry about our images, our container images,
Sure.
and keeping those up to date. And we have to worry a little bit about port exposure and things like that. Now full PaaS is going to be our things like app service and our functions. So things where really we have to write the code, but Microsoft is handling all of that server stuff for us, which is why I think maybe, there's this middle layer when we start to think about containers, maybe between the two. And then finally, all the way at the SaaS side, we're basically talking about Office 365.
Software as a service, right? Here it is, complete app. We built it, we run it. You want to run it, it's cool. You can do that, or you can run, pick another, email, right, or whatever.
We wrote the software, you just execute it.
Yeah, there it is. You use an application. It's not installed on your machines. It's not installed on my machines. You just use it, as it goes. So
yeah, and so as David was pointing out early on, we have a spectrum here now. We can do everything, including writing the code, running the servers, buying the servers, updating the servers, etc. Or we can start to blend that responsibility all the way until we didn't even write the code. We're just using the Excel application that was created for us.
Right, and you're giving us the data, and we're doing stuff with that data, and that's what you're responsible for. It's your data, right? And so that's what that picture shows.
All right. And we're having a little bit of hard time advancing slides again. I apologize. There we go. Here's another one of your favorite slides.
Yes. If you happen to have a toolbox, a pen, a hammer, some paper, and a ruler, you too can build an ideal architecture.
But you don't have a pen, therefore.
Oh no! What do we do? I think what we were just trying to say with this extremely high professional slide here is just like, hey, it's like a physics problem. Like, imagine a perfect sphere, but the thing is that it's not. Right. So there's a reality. And this is exactly to go back. I think we're going to just pick up Michael this entire time. Go back on Michael's comment. Right. The pillars are always interacting with each other. And we're going to make sure to talk about that as we head off into the pillars.
Yeah, I seem to recall that a few minutes ago you were really excited to talk about the first pillar. And I personally call this the David pillar.
Well, I'm pretty sure that I don't know if I want that, but I do dig it. Okay, so what is reliability? You probably kind of know that, but the thing is, you kind of understand that anything can go wrong, and reliability is all about expectations, right? Where people have these expectations on how the software is going to function. But people, when they talk about reliability, often talk about it as if there were just one kind of expectation. Let's go to the next slide, because I think
and that expectation that people usually talk about is that uptime, right?
Right. So when people talk about reliability, usually, and we'll advance this one bubble at a time, they're usually talking about availability, right? They're talking about, is it up or is it down? But the thing is that it's really important to understand that that's not the only thing that goes into reliability. Another thing you might add to reliability would be the next bubble, which is latency, right? That's like how fast, if I send a request to your service, how fast do I get a response back? And we know now that sort of slow is the new down, right? Where if your website, your service, or whatever doesn't respond in enough time, something else is going to break, or your customers are going to go elsewhere, and nobody wants to use a really slow website, right? And we just know that from that. That's one way to lose money. But there are other possibilities for reliability. There's throughput. If you're running some sort of batch system, or you're running some sort of pipeline system, you might really care about throughput. Or
latency and throughput, I love that you've got them right next to each other too, because those are also confused by folks often, right? We'll hear people talk about, quote, bandwidth, meaning both latency, how fast it responds no matter how much data we're dealing with, or basically how big the pipe is, how much data we can send and get performance at scale of sending data.
Yeah, so how fast can I process what I've got to process? Yeah.
Talking about things interacting together like we do with the pillar, but we also, even within reliability, we can see that sort of interaction.
Yeah, and so, but there are other things here that are a little more niche, but still kind of important. One of them is coverage. Like, did I process all the data that I had to? Did I make it all, if I'm running a batch processing system? Or the next item here is correctness. When I processed it, did I do what I expected I was going to do? Like it seems sort of obvious, and yet you would find it's really impressive that people don't necessarily pay attention to correctness as a reliability measure. But if
the API returned 200 okay, so as far as I'm concerned, it's good.
Yeah, it must be fine. Everything's groovy, right? What could possibly be wrong? So fidelity is a little trickier to talk about, and I'll try to be really brief about this. Fidelity is what happens when you're trying to measure whether you're providing the entirety of the experience you plan to, or whether you're providing something in a degraded state. The example I give is when we're talking about something like Netflix, right? So if Netflix is made up of like hundreds of microservices. Thank you. That's what I'm trying to get out of my mouth. And if one of them goes down, let's say the recommendation engine goes down, they don't give you this white screen that says, sorry, no movies today, can't do that. What they will do is swap in, or it'll take a piece out of the picture, the page you're looking at. And so fidelity is that measure of how often did I successfully provide the 100% experience that's there.
I actually want to zoom in on fidelity, and actually specifically even that streaming example too, because there's something interesting when it comes to video delivery over the internet.
Yeah.
You did the example of microservices, and maybe the video is working, but then, oh well, if I can't get the rating, so what? Still play the video. But actually, video itself is designed. Streaming video itself is designed in a way to provide graceful degradation. And so this is another prime example of what you're talking about. When you're watching a video and you realize you're only getting that 200 by 400, resolution, blocky and all that. That's actually carefully designed into the system. Our video compression algorithms are designed to not just send a frame. So it doesn't send a frame of data at high resolution. The way it goes over the wire is a minimal resolution, whatever that minimal resolution is, and then it starts sending packets of refinement, and those are actually built to refine what it already sent. And so those are the first things to drop, so that it can send the next minimal viable frame if we start to see that we don't have sufficient, going back to throughput and or latency to do what we need to do. So it has that built-in degradation in the specification for streaming video.
And from the reliability and expectations perspective, if you look at it from the customer's perspective, which we're going to talk about this, they're expecting to get, whenever possible, as high, a service level, a level of high fidelity, right? So like if in fact someone says, I used to use YouTube, but now I only get blocky video, they're going to go elsewhere. And that's another reason why you want to measure the fidelity of what you're actually delivering.
A final point on this, and then we're gonna move on to freshness. But there's still that push and pull of you're right. We've already not given them the fidelity they want, but someone somewhere, and that hopefully was a careful product manager, made that decision that realized, our customer will still find our reliability to be higher if we give them
Yeah.
consistent playing video versus video that stops, but on a full resolution frame. So we made that trade-off. That was a conscious decision. Hopefully it was a conscious decision.
Right. But everybody will be very sad if you know, the business will be sad if in fact people think they're not getting what they paid for, right? So that's where the expectation comes in. Freshness is another one where, let's say you're running a site that does sports scores or election results or something like that, so that might matter. And then one more thing that I want to say as part of reliability is, and there's others I'm sure other people can come up with, durability. Like if I'm running a storage system, I need, and I write a bit, I expect to be able to read that bit back in, you know, and so you need to be able to deal with that. To quickly answer the question that Michael was asking about is, does availability include high availability? Yeah, that's a method or an attempt to come to a goal as to what you're shooting for, and what do I need to do to make it high available? Well, probably there's things I need to do to make it more fault tolerant. So I suck all these things into the reliability bubble for a good reason, and I think if you click one more time, I'll show you what that reason is. What's the reason? Show me the reason. So the thing that I want to say about reliability, just because I'd love to spend the entire time on this pillar, but I want to just sort of nail this thing at home, because if you go back to your life with this particular advice, I think you'll be in good shape. Reliability is measured from the customer's perspective, not the component perspective. And I'll say that again. Reliability is measured from the customer's perspective, not the component perspective. And I will drive that home with our first honest to goodness poll. Okay, so let's assume that everybody on this call really wants to sell tote bags for a living, and with clouds on them, because, you know, cloud, Azure, et cetera. And so in order to do that, you set up 100 backend servers, and we're sparing no expense because I have pasted 100 backend expense. And yes, and our producer is getting ready to set you up for the poll. I have set up 100 of these things, and something happens in the data center, and 14 of them burst into flame, or at least maybe they get a bad OS release or something, and they're broken. So now I have 86 machines in my backends that are working fine, and 14 of them are failing and aren't working. So here comes your poll, folks. Is this situation A, no big deal, I can sit on the beach, drink my fruity drink out of a coconut with a little paper umbrella, and I don't have to worry about it? Is it B, I should walk back to my desk right now and go deal with this situation? It's pretty serious and I should deal with it. Or is the situation C, it's an existential crisis, I should scramble everyone. If it happens to be 2 a.m., too bad, I'm still going to call the CEO at home or the CTO at home and say that we got a problem, please get on a bridge with us. Okay, people should now vote. Where's DJ Laurent when you need him for the video?
Where's that sweet publicly available music?
Okay, I just want to suggest that we should never, ever, ever tempt the fates by asking our producer.
I think we should tempt the fates yet some more.
Okay, well, maybe we'll do that for the other ones. Okay, so we're looking for the. I really appreciate people voting. Thank you for taking the time to vote. I'm seeing that sort of B is currently the big winner amongst these things. There's been 12 voters. I'll say let's get to 15, and then we'll move on. So if you haven't voted yet, pretty please do so. Or maybe we'll just stop at 12. I'm fine with that. 13. Oh, we're getting there. This is like a telethon.
Right?
Only you can save poor Jimmy.
Asked for money. You know, in fact, I wanted to say something more about high availability, since we had that question, and while we're waiting for some more responses. You know, I think, you know, high availability is to some extent is a blurry line anyway, right? We know that there's a sliding scale of availability is important. So high availability, we can define exactly what that means in terms of the number of nines. We need to be, up 99.9999% of the time, but it's a bit arbitrary. What's key is that we start to identify patterns that are important, and different methods of operating, both in terms of our hardware or our Azure services, as well as our operational practices, when we've decided that those are the important things to do. And, to some extent, that gets to the answer I think that David wants to let us in on for our poll here.
Yeah, let's come back to the poll. And by the way, I just want to say, Jason, I have this nice controversial shirt that I like to wear that comes from Charity Majors that says, "Number of nines doesn't matter if your users aren't happy." So just want to say that. But the question here was, okay, see, we're talking about like measuring reliability. The question was A, is it no problem? B, do we need to fix it? Or C, is it a crisis? And the answer to this question is, sorry, folks. The answer is it depends. If you've architected your system in such a way that nobody notices there's a problem, that nobody can tell, maybe it's A. Maybe you sit there and you just enjoy another Mai Tai or whatever it is you drink at a beach. I don't know what good beach drinks are. B,
Mai Tai is acceptable.
or if there's a real problem, like you may have to go back to your desk and deal with it now. That's an entirely possible situation. But if you find C, that you're hemorrhaging money, the thing that your company does isn't working and it's crucial it gets up, it might be C. So it really depends. And so what I wanted to say about that before I get to this reliability slide here is, that's an example where I told you 86 were working and 14 were not. I gave you something and I said, like, okay, so tell me if that's a problem. And in that case, what was important was not the components, it was what the customers saw. And so that's really kind of crucial. But I think you're doing a good job of leading us right into the land. I promise other polls will be a little less, trick questions.
A little less trick questiony.
Yeah, I promise. Some of them will be very not trick questions. You'll wait till you see our polls.
Why are you even asking me this, David?
Oh, well, so there are lots of words in this constellation about what reliability is, and so let's just walk it through here. Okay, so high availability is that goal, right? Where you're saying I want to engineer stuff in a way where I have a certain amount of availability, right? And to that extent, you might use techniques like fault tolerance to make sure that things things handle themselves well if something breaks. I.e., it's more fault tolerant if you have two of them and the other one can take on the capacity, right? Like that's a fault tolerance thing. And another way to get to fault tolerance is things like redundancy and clustering, right? Like that redundancy thing I was just saying, if you have more of them or if you have a cluster of them, that can sometimes help.
You can spread the load, right? So you can have multiple servers doing the same thing if it's just a lot of instances of X.
Yeah,
they can share.
Yeah, and if some of them break, cool, not a problem, because the other ones are going to take on that load, and you just have to work
just slightly more X.
Yeah. Okay. Yep. Then there's recovery, right? Recovery is that question of how quickly can the situation recover, and resilience is the thing that people get wrong all the time. To a certain extent, resilience is adaptive capacity. What is the ability to respond to a situation where you are trying to where you or the system, and when I say the system, I mean either your computers or your computers plus your people, because everything is sort of socio-technical, can recover from what's going on. Oh, look, there it is, socio-technical, and can recover, right? And have that capacity to do that even under situations where they haven't seen this problem, right? Because if your thing just reboots itself when there's a problem, that might be fault tolerance. That's not exactly resilience, right? If you have a bunch of people who know how to bring more servers into play, that might be closer to resilience than fault tolerance, right? Where we're like, oh, okay, I know how to deal with this. The thing that I want to mention is things are socio-technical. Every large system is both made up of people and machines, and they're both really kind of important. And the last thing I just want to say about reliability that comes from site reliability engineering is that once upon a time, we used to think everything had to be up 24/7, 365, 365 days a year, et cetera. And I'm here to tell you, folks, that one of the things that we've understood is that shooting for the appropriate level of reliability is really quite crucial, right? Because it's not necessarily the case that 100%, in fact, very rarely is 100% a useful goal for a number of reasons for shooting for reliability. And I leave that somewhat controversial statement hanging in the air, as I think it's time to move on to another pillar, right?
I really can't let a discussion with you about recovery and resilience go by without saying, I get knocked down, but I get up again.
Yes, there's nothing like a little Chubbawamba on your stream to go this sort of thing. Careful, because I know a certain DJ who's going to go, oh, it's a knowledge check.
Do we get the DJ for the knowledge?
No, I don't want the DJ for the knowledge check. So this is going to be another poll, folks, and these are coming right from the
Learn
right
module.
from the Learn module. And I just want to say clearly about this, that some of them, these are taken right from the stuff that we didn't write. And some of them are going to seem a little, I don't know, easy, might be a nice way to say it. But we thought we'd leave these in because they give us a chance to sort of riff, because sometimes these things are non-intuitive. Just, like there's more behind what's there. So, okay.
You can tell that we need a chance to riff, because otherwise we're just very stiff and just read right off the slides, right?
Yeah, right. Yeah, that's a real problem. Okay, suppose you want to increase the availability of your system to provide a better service level agreement, SLA, to your customers. We should talk about that in just a second, which is why we decided to leave this in. Which of the following is a guiding principle you can use? A, reduce your target for maximum duration of acceptable data loss. That sounds like something. Encrypt all data at rest. Or C, eliminate your single point of failure or failures. So if people would be kind enough to vote, that would be super swell, and let us know which one you think. I know this is super hard. The thing I wanted to say about this and why we left this particular question in is that I just want to make sure from a reliability perspective that people understand that service level agreements are basically legal agreements, right? They're not engineering terms per se. They're the thing that you say, hey, I expect this amount of reliability or this amount of service from you, and if I don't get it because you have a downtime, you owe me something, money,
indemnification.
yeah, or something happens. And so the thing is that when I talk to other engineering folks about stuff, we use SLA sort of as a shorthand for like the expectations, but you just have to understand that they're a legal concept. They're not an engineering concept. They're an agreement that I make with you, or you make with us, or Microsoft makes with you. And so I get really, when people talk about SLAs in this case, it's much better for me to talk about service level objectives, which is what is the objective for the service, not like what is the legal agreement that you and I have if the service doesn't behave in the way I want it to.
Yeah, I'm glad you made the point of differentiated that point, because I do think it's important for folks to realize that when they're talking to others, people will use SLA in a I don't know, maybe lazy form way, but informal way, I think is the best way to say it.
Yeah.
Just like you said, so sometimes when people are talking about SLA, they're actually trying to get to the point that you made just a few minutes ago, David, which is 100% perfect is not usually the goal. The goal needs to be defined in a more realistic and meaningful to customers way. And so often people are using it informally that way. So just kind of understand when you're talking to folks, which way they're using it, the formal way or that informal way.
Okay, so I'm seeing that people have voted, and thank you everybody for getting to this voting thing. I hope you're going to enjoy it. So it looks like most people think it's eliminate single point of failure, with some people think it would be kind of cool to reduce your target for maximum duration of acceptable data loss. What is the answer? It is single point of failure. That's right. I think the first one is not terrible. Like, that's cool. That's a target. But if you want to increase the availability, ideally the thing that might be getting in your way of availability is the fact that if this little thing over here goes down, then everything goes down.
Yeah, I think we could say that A would affect overall reliability, but not specifically maybe.
Yeah, well, it's specifically about data loss, right? Which is not necessarily availability. So that's where I think that's semi-tricky the questions. Okay, second thing. Which of the following would be affected by your defined recovery point objective, right? Which is your objective of, let's say something goes bluey, how quickly can you come back to where you want to be, which is kind of weird because RPO doesn't get really talked about in this thing that much as well, but cool. But it's like, if I want to recover, which of these things is true? A, the frequency of database backups, if I want, would impact that RPO. The number of regions that the data is replicated to, the number of instances in a database cluster, or D, the type of load balancing technology used in your application.
All right, back to the polls, please.
Yeah, so we're back. We're in Poland. That's not what I didn't really mean that, but Poland's cool. While we're waiting here, I just want to say that I appreciate, Ellen, you're asking if we could show you how the architectural framework works. The way it works, quite frankly, here's your big secret, is you say, these are really important topics and we need to talk about them. There are ways to then use stuff where I don't think we're going to demo it this time, but you can use some of the assessments that are online online, and I think those are in the resources here that allow you to go through these basic assessments to ask yourself these questions about reliability and security and cost optimization that can then help you take actions beyond that. But it's meant to be sort of this conceptual framework to say, well, what do I need to think about and what do I need to talk about with my team? Presuming you have a team, right? So that's the way it works. It works a bunch of it works by passing air over your larynx, just to be abundantly clear here.
It helps with a jumping off point, and it often we'll dive deeper in our well-architected guidance and the questions that we coach ourselves to ask and coach you to ask. We'll dive deeper into a lot of the services and technologies that Microsoft offers, but it's a jumping off point. It's a framework for thought, for planning. It's not say a development framework, right? It's not something where I'm going to go through a click through and have an application built. It's definitely an architectural, a planning level framework. And a lot of the things, to be honest, are things you probably know, but you've known over the course of years or decades, and seeing it organized is immensely helpful. To see it organized when you're sitting in front of a blank screen and go, okay, now what do I need to do to adapt what I already have, or start planning a new application, or heck, start sunsetting an application, all those things, whatever phase you're in. Sometimes you just need that help to say, all right, where's the checklist? Where's the framework to think about those things I already know and kind of put them in perspective?
Yeah, how do I frame it? How do I talk about it with other people? Like, we're hoping that some of that's kind of rubbing off as a second order effect. Okay, what's the answer, Jason?
All right, it's the number of database backups, and it looks like our majority of voters did hit exactly that, because of course, if we are backing up frequently, then we can go to our most recent backup, and we're going to be closer in terms of point of time.
Yeah, and that's in terms of the time thing. Yeah, the other things do feed in a little bit, like having backups all and being multi-region definitely feeds into it. But I don't know about you. I think it's time to get into security.
I don't know. I'm always uncomfortable getting into the topic of security.
Good, right? Like, okay, so this is what happens when you have a cloud with springs or electricity or something.
Don't forget the padlock.
Yeah, we did not make these pictures, folks. Can you tell? But data is the most valuable piece of your organization's technical footprint, sure. And I think this is trying to mean that, like, you could get zapped by all these different things.
And data, let's be clear, data does not mean what's sitting in your database necessarily, or sitting on your file system. It means literally everything. It means the stuff that's sitting in Active Directory. It means the stuff that's going over the wire. It means the stuff that is encrypted, but do you know where your keys are? It's 10 p.m. at night. Do you know where your keys are? It's everything, right? So data really, when you get right down to it, it's everything about your system. Heck, it could even be your application code in some cases, right? So it's everything.
Okay, this is a little too deep for me. I think we need to go to the next slide. If everything, what is security? Okay, I'm pretty sure everybody knows this.
Then what is security ought to be a nice, easy topic.
Okay, yeah, okay. So now we've done that. Sorry, we're not intentionally insulting your intelligence here, but you're good. But this is actually something that's useful to say, because one of the things that it can be very easy to be scared, as you said, when it comes to security. And one of the things that can help is to sort of understand ways to think about it. And one way to think about that is this defense in depth thing, right? Where the idea is, in order to really deal with this and to be the most secure you can be, you really need to sort of do this multi-layered approach. Because each one of these layers repels certain kinds of attacks and certain kinds of attempts at not goodness, so.
Yeah, in the layered view, I mean, it makes sense, but it also, to some extent, I feel like misses a certain point, which is that all of these things interact, and all of these things, if there's a breach in one, can cause a problem for the rest. So for instance, I mean, we have physical security on the top. If you look at this picture, you might think, well, if your physical security is on point, then you're fine. And that's very wrong, right? I mean, we have things going over the wire all the time. I mean, our wires leave our physically secure data centers and our physically secure office buildings. And if we think about the shared responsibility, dual responsibility, David, model, we may have our servers secured because Azure is hosting those for us. But that isn't all of physical security either. If our laptop is left unsecure at a coffee shop, then we have violated physical security. When things are going over the wire, if we're using an old web form with basic authentication that also happens to leverage our Active Directory credentials, then guess what? We just gave our Active Directory credentials to the world. So there are a lot of considerations that don't just allow us to treat these as nested. And that's why we talk about defense in depth. That's why we don't just say, your outer shell needs to be good, and if your outer shell is good, you're fine.
Yeah, and I just want to say that lest people freak out, because I would. Nobody can do all the things simultaneously. You need to sort of pick and work on one and then move to the next. Like, just to understand this, like it's very easy if you look at this to say to be overwhelmed and say, well, and it's just not an option. So to a certain extent, just to understand that you're probably going to be working between various things. It also might be the case that some of the stuff that's here is not your responsibility in your organization. It's entirely plausible that you have no control over the physical aspect of things. You're not the people that give badges out, and so it's up to other people to contemplate it. So we're just trying to put a little bit of nuance into this as you as you live your life, sort of thing.
Fair enough. Here's quick examples too. I think it's worth.
Yeah, that's helpful.
Yeah, just the kind of letting we don't often just say, well, we're going to sit back quietly and just let people read the slide. But I kind of like that on this one. It's just to look over some examples.
Yeah, and so the basic idea is that encryption can be a problem for your data layer. You can do all sorts of really cool stuff like SQL injection when it comes to the application layer. You can have malware, which we're seeing a lot more of these days. Brute force attacks, open ports, DDoS attacks, other stuff like that. So
and again, thinking about how any one of these is kind of independent, right? No matter how well you've secured your data center, and no matter how well you've written your code, a DDoS attack is still something you could be in trouble for if you don't have a more advanced networking architecture than I'm capable of designing.
Or having a response, or at least knowing, or I would say, Jason, or at least knowing how to bring into play something like that. You may not have to write your DDoS protection system, but knowing that there's a way to turn it on or to access the one that Azure provides might be the thing you need, right? So it's
knowing the questions to ask and kind of how to go about finding the people to ask.
Yeah, you don't have to build all this. You just have to know you have to think about it. That's what I guess what we're saying. And again, it all comes down to you could people get in the place. Okay, so physical security. So I guess we're gonna give some. That's where the outsourcing question comes in, right? Where it is probably the case that for many things you are going to not actually be doing this as part of your daily life, right? Unless you're in the security group of your org, which you might be, which would be cool. At which point, say hello on the chat. We want to say hi. Shout out to all you security folks. But the nice thing is that if you're using stuff like PAS, we've done a bunch of stuff for you. Like we're going to be, you don't have to ever patch an OS if you're using PAS. You just don't even see that. We just do it for you, and we try to do it in a way that allows us, that does it in the way that's least disruptive. And we're very careful about that. Identity and access control, network configuration, application configuration. You can push this stuff out to us. Much of the stuff to us. And in some cases you have. We're not, Jason and I aren't standing in front of the Azure data centers, and neither are you, but we have some really competent people that are making sure that those are secure. Okay. Oh, and now a knowledge check. I'm going to call it every time that way because I like it.
I think the C is silent.
Oh, knowledge check. It's the Israeli version of the knowledge check. Okay. Which of the following types of data might need to have security protections? Why don't you read these, Jason?
Customer data that contains personal information, financial data that supports business operations, intellectual property, or D, all of the above might need security protections.
Please get this right, every single person on the call, please.
You're not supposed to do that.
Somebody out there is going to just mess with me. I just know it, but I'm just telling you.
It's me. I'm going in right now to answer.
Yeah, I have 100. I have a whole botnet just as of 18 people that are answering questions randomly.
That's what we call social engineering, folks. He just forced all of us to answer it incorrectly.
There you go. Okay, which one? We're at 20. Go for it. Yeah, of course. Like, duh. Okay, good. I'm sorry. I'll stop saying duh. That's just like it's being rude to you and it's being rude to the poll. But it's pretty obvious if you've been in this business at all.
If we have that all of the above, be careful in all of the above is probably a pretty good
yeah.
In general.
Okay.
Which of the following? It depends.
Yeah, which of the following is an example of an attack you might see at the policies and access layer?
Is it exposed credentials posted online, a SYN flood attack, following an employee into a data center without presenting credentials, or ransomware that encrypts the disks of a virtual machine?
Okay, I see you're pushing a comment to us. Thank you, DJ Laurent. Yeah, okay, so let's try this one. This one's a little harder. I mean, I think, especially if you don't know what a SYN flood attack is or stuff like that.
So glad we defined all those things before asking them the questions.
I know. A SYN flood attack, for those of people who don't know, has to do with sending a particular kind of packet that's part of the TCP/IP handshake. And if you can really mess with somebody else's networking stack if you send them enough SYN packets.
This is the one that fans out, right? It creates a fan out replication, so it basically starts overwhelming not just the one you're sending it to, but it tells that one to essentially overwhelm everybody else too.
Yeah, it's fun. Oh, sorry, fun is probably not the right word, and never done that
all
before.
Right, so folks.
Oh yeah.
Answer.
Yeah, so the key here was the word access layer, and I understand how physical access might get the two people that voted to think that was what we were talking about, but it was a good thing. Interesting. This was a little more spread out in terms of vote there. So something to contemplate when you look at like what are the layers that may be useful for you to check out. Okay, next thing
is our next pillar.
Oh, money. Sorry, do we get permission to sing that? I forget.
Sure, we did not.
Oh, great. What could possibly
happen? As long as you don't sing the happy birthday song, we're going to be fine.
That's actually no longer under. Anyway, why are we talking about this? Let's talk about cost optimization. See what happens. We can both get off track so easy. So, okay. So here's the thing. When we talk about cost optimization, we want to be clear that we're not saying what is the smallest bill possible, right? Because that might be something that you might think cost optimization is. How can I spend the least? And what we're trying to suggest is that cost optimization, because you're spending money for a reason, right? Like you're here for a reason, and it's not just for giggles.
You're trying to deliver something. You have an application. It's a need to deliver something, and you still need to do that. You still need to be reliable.
That's right. So the thing to understand is we're talking about cost effectiveness. We're talking about using the money to its best, using the money for its, to its best use, right? Not wasting money. Like you want to make sure you're going to spend money, so you want to get your value for that money.
It's bang for the buck. It's right. So yeah, and you maybe you're spending too little. If you can clearly see that spending an additional $1 would make you $2, then you're spending too little. So cost optimization isn't just shrinking your spend. Maybe it's spending more.
Right. And let's say you're in the US and you have to deal with a Black Friday situation, or you're in China, you're dealing with an 11/11 situation. You're dealing with, any of these other situations where you have this huge spike in traffic. If you go down during Black Friday, your biggest chance to sell a lot sort of stuff, that's a big bummer for you. Right. And so you may want to spend a lot of money on that day to make sure it goes well. And I know teams that spend entire years prepping for that one day. I mean, sorry, the whole part of the year. So, but what do you do about this? Well, so first step is you can start out with this question about how much is it going to cost? And the plan and estimate cost, there's a nice pricing calculator that does its best to try to say to you, oh, well, what kind of things do you want? And what kind of scenarios do you want? Let's sort of get you in the ballpark so you can get to estimate your cost to see, when you're first starting out. And that's what this pricing calculator thingy is.
In a sense, we could put this in that dual responsibility area too. So when it comes to cost optimization, what value you're getting out of services. We, in the terms of the pricing calculator and our other tools, can help you understand what the cost is. And then now you can take the cost and the value, and you can figure out where you want to put things. How much do you want to spend given the value you can get out of it?
Yeah, and it really is like this thermometer back and forth, right? Like where you want to be. The other thing that you can start to do as you're doing this is that there are certain there are certain services, like things like, I think we'll talk about reserved instances later, right? Where you can provision the services that are already kind of optimized for cost from the outset. And what that means is if it's like saying if you build with the things that already have cost in mind to start with, it makes it a lot easier than later on when your boss comes in and drops a 400-page phone book sized Azure bill on your desk and says, what the heck, to be able to say, no, it's like you don't have, it'll be a lot easier should you find yourself having to figure out, well, where do I do more optimization? It's really good to be already using the things that have that built in.
Yeah, to your point, it's not actually to maybe go back on your point. Maybe that slider you were talking about, as you said, maybe it's not that simple because we have different cost models for different roughly equivalent services sometimes, and sometimes when we choose from one service to another, we may actually not even be. Look at the different database options we have. We're not always simply choosing based on functionality strictly what we're going to use. Sometimes we're matching up the cost model to our utilization model before we even decide how to architect the app, before we even decide which service we're going to be using for data storage.
And it's not always easy here. Also, is an acknowledgement that omniscience can be really hard to come by these days. So it may be the case that you were later on in production now understand that, oh, I am using much more of this thing than I thought I was going to have to use of this thing, or we're getting more of this kind of traffic, or our database stuff is trickier. And so just want to say we get it. Like we get that sometimes you have to iterate. The thing that's really useful about this is I actually really dig our tools that sort of show you like what your cost is, where are you spending your money? Because the cost tools that are in the portal are pretty hot from my perspective, where you can say like, oh, I see, I'm spending all this money here, or I predict that I'm going to go above a budget. Like you can set a budget, or you can set limits, and it can let you know when you do that. And so it can really give you a really nice understanding about where are you actually spending your money, and it may not be where you want to spend your money. And that's super cool for me.
Yeah, they haven't always been that good, to be perfectly honest. To be totally transparent, they haven't always been that good, but they are really, really useful now. It's really pretty easy to drill in and see exactly where that money is going, starting from any perspective, at the subscription level, at the resource group level, drill in all the way down to a service, and then the individual services. Many of them are very good at telling you exactly within that service where the dollar spend is coming. So we've come a long way in terms of letting you know where your dollars are going, so that you can start to make those good decisions.
And I also want to encourage people to set up budgets and set up the things that have alerts associated with them. It's much, much nicer to have something say, hey, you seem to be reaching your 75% or whatever it makes you comfortable, or 50% of your spend, and it's day 3, right? So I just really encourage people to set that up, because it's far better to get that news before you spend the money than after you spend the money. But other stuff you can do if you're trying to deal with this stuff is you can do your best to sort of maximize the efficiency, or as we say, reduce waste, which sounds a little something. But what do we mean by waste, right? So so waste is like a virtual machine that's not doing anything 90% of the time. That could be a waste. Now, again, there are situations where maybe you do need something hanging out there because the 10% is really, really important. And so you want to make sure that you have something that doesn't have a slow startup time. So you really do have to leave stuff out there. But most of the time, if it's 90% idle, you can sort of, get rid of it. Or
we'll go back to that. But going back, it's not always simple. Let's think about that idle machine. If that was a reserved instance and you pre-bought that because you made some very careful calculations that during this window of time, there will be spikes, but sometimes it'll be 90% idle, then you still made the right decision, even though today it's 90% idle. So it's complicated.
The other thing is that sometimes, and I don't know if we have that in this deck, but sometimes you can also be really smart about how do people really work in your world. So if it is the case that during weekends, nobody touches your dev environment or touches your staging environment, you could tear it down over the weekend and put it back up again, or make it go idle, like shut everything down so you're not spending money. Like there's cool ways to do this where if you just, you understand the general context. Azure has no way of knowing like how you generally work. But if you know how you work and you can optimize based on that, you can save a bunch of money. Other stuff that's on this thing, right, is saying, like, let's say you've got data that you don't really need all that often. There are cheaper tiers of storage that you can store it on, right? And it might be a little slower to pull it back, but if you very rarely need it, chances are you could stick it on ice, essentially, right? Also, the nice thing that's also useful is that there's sort of these cool hybrid benefits, right? Where you bought a license, and there's also already a license. You shouldn't have to buy licenses twice, right? And granted, licensing is a dark art that involves entrails and
tea leaves.
Rituals in the evening and stuff like that.
I don't want it to get darker than entrails, so I'm just going to go with tea leaves.
Yeah, tea leaves is better. Yeah, I know, but I really think it does involve animal sacrifice. Anyway, but you didn't hear that from me. Okay, and manually repeating the build of a non-production environment. So that's an interesting one because the word manually to me is the key word there, right? Which says that, like, hey, you want to build a new environment. You could spend some really expensive human time to every time they do this to go manually follow this Microsoft Word document, or if you could stick it all into an ARM template and have it come up so that the machine does the work, that could be a lot better, right? And so you wouldn't be spending as much staff time, which is also, quite frankly, a part of the cloud spend. Like, it's not just what goes on your credit card here; it's the cost of your staffing. And so sometimes there are ways to do that through automation to reduce your staffing costs.
Ready for another knowledge hack?
I would like a knowledge hack. We're gonna just beat this name to death by the time we're done here. Okay, here we go. Which of the following is an example of waste resulting in an increased resource cost? A, archiving infrequently accessed data to an archive storage tier. B, using a service that automatically adjusts resources in a provision to match user load. C, pulling databases to share provisioned capacity. Or D, running a development environment overnight that is only used during business hours. I'll give you a hint.
Somebody may have given you the answer to this one already.
Yeah, we kind of said it. Everybody paying attention, pretty please click on a paid attention answer. Yeah, there you go.
Keep on going. Looks like everybody hit the paid attention answer. They were listening to you.
Us, Jason.
Us. All right,
and look, people are getting really quick on this polls, and I just want to appreciate you for the participation, folks, because this is because we can't see you ordinarily. It'd be really great to do this in front of you live, though I think it would probably freak out your household if both of us showed up at your doorstep. But we missed the chance to interact with you, and so I really appreciate people taking the time to click on polls.
That's a really great point. It's a really great point. While y'all are looking at us, we're just looking at each other. And so all I know is that David is sort of paying attention to me, to the fact that the getting the answers on the polls, the interaction with the polls, and the comments that come in through the chat is super nice. It's super motivational to know that we're still all here having a conversation, even though the video only works one way.
Yeah, and I got to say that if conversation includes clicking on a poll, that's true.
Give me a break, man.
Okay, fair enough. Okay, well, we're done. Okay, so the vast majority of you think that running a development environment overnight that is used only during business hour is wasteful. I would agree with that.
Would you?
I think that A may be a little fuzzy for people to understand what it was trying to say, which is basically saying, hey, if you're not using data, put it in an archive storage store. An archive storage store is what I was talking about, putting it on ice, which is sort of the cheaper level of storage. And C is pooling the database to share provision capacity, is again saying, like, instead of buying one very large thing, or instead of having databases that are running idle and having 3 of them that are running idle, if you could make them all work together, then you can use some of that idle time and you can have fewer of them.
And you'll often have multiple applications, say, that use Microsoft SQL Server. And so those multiple applications can share some resources.
Right, with the proviso. So maybe the thing to understand here also, however, and this gets back to our original thing about trade-offs, sometimes you can do that or sometimes you can't. Sometimes it's really important to keep the data segregated. Sometimes you have governance issues. Sometimes you have issues around
peak load.
Say what?
Peak load.
Oh yeah, right. Sorry, noisy neighbor problems. Right, you got to watch out for that. But sometimes you also have issues where, like, I'm not allowed to take this data outside of my country. right? You just have these requirements, so it's not possible to do that. Okay, you want to do another poll. Let's do another poll. It looks like it's a larger poll. Which of the following is good practice to reduce costs? A, conducting regular reviews of cloud bills to identify abnormal increases in spend. Seems like a reasonable thing. B, letting all IT teams have access to provision virtual machines of any size. That sounds really interesting. But I want to tell you, having been on IT teams that were really good people, C, provisioning the same capacity in development environments as for production, even though resource requirements are substantially lower in development environments.
That's a wordy option right there.
Yeah, that's saying that you build out the same stuff for development and production, even though you know that production is going to require a lot more requirements, a lot more capacity. And D, provisioning virtual machines that include licensing costs rather than using your bring your own license image. You know, I don't know. Pretty please vote. Pretty please vote.
That's right.
Vote, vote, vote. Vote, 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 vote. You know, vote now, vote often.
I have my commentary in yet. I'm pretty sure that would be spoilery. Let's see how many votes do we already have in here. We got a pretty good number in. I'll start being a spoiler. So I will say, C, our wordy option here. It's not cost effective, but I know teams, especially in the on-prem world, that religiously did this because for their environments, because load does not necessarily scale with resource use. So if your resources spike with your first user and then you elegantly scale to 100 users, well, you need to have all the resources with the first user. And if you haven't done enough testing to know that, all you know is that with the server that you tried, it works, then you just have to roll with that same server. Again, that's not necessarily the most cost-effective or efficient option, but there are sometimes time to market concerns that trump all.
Well, I will defend that C in a slightly different way, even though I may or may not agree that that's the option, but I defend it like so. One of the things that can be a real problem is if your development environment and your production environment don't look similar, right? And so you go testing stuff in your dev environment, and your dev environment isn't multi-region, but your production environment is multi-region. You are not going to see the distributed system issues in your single region thing. You're not going to have the same speed of light problems or issues. So there are some really good reasons to want to keep them the same. I think the word capacity there might be different, but I want to suggest that they better look pretty similar, or you're going to find yourself debugging in production. But really, the easy answer to this is A, conducting regular reviews of cloud bills to identify abnormal increases in spend.
And of course, this question was specifically about cost optimization. So all of the points that David and I were making do not apply to cost optimization. They apply to other good practices, sure, but not cost optimization. So C was right. Not the correct answer. A was.
Yeah, and I don't know about those IT teams, man. They seem a little shady to me. Anyway, okay, next. Suppose you have recently moved your application to the cloud and your monthly bill seems higher than expected. And I'm here to tell you that's not unusual. The utilization level of your VM is high enough that you're hesitant to downsize. What might be a reasonable next step you can take to help you find inefficiencies? This one's actually a lot harder than you might think. So let's go through them. A, wait a month and recheck your bill. B, increase the amount of application testing you do before each release. Or C, add monitoring and instrumentation to your application. This is a really hard one, folks. I want to just tell you that I personally think, I think we need to roll, okay, good, great.
Boop,
boop, boop, boop, boop, boop. I noticed that the voting is slowed down on this one because I said it was tricky, and I'm very pleased that you're taking your time to think about this because it's not super easy. Boop, boop, boop. Nope, people seem to have an opinion here.
I need to refresh my screen here. Not getting the results.
I'm getting results.
Well, that's why I'm refreshing. So I think I'm going to start my kind of a spoiler commentary now too.
Go for it, man.
You see we got the results. Depending on your situation, Adding monitoring and instrumentation to your application, especially if we're talking about code changes and having to make sure that you're not breaking anything in the process, that might actually take longer than waiting a month and rechecking your bill. So you actually might be doing both of those.
Well, I will spoiler this in my way. In my world, if you are waiting until you get your first bill to add any sort of monitoring and instrumentation on your thing, you've got bigger problems. Oh, but oh, good. That's C. That's really interesting. So this is really fun because it may be the case. So here's the other thing that I want to point out. If in fact you looked at your bill in December, if you're in the US, you might find that bill is way higher because it's a commercial, it's a high commerce month. January, your bill might be less slower. It might be fine that you have larger than you expected in that month. It could be seasonal. So I just want to say that the people that voted for the other things, I kind of think that that's reasonable as well. But I also want to think about if you're doing it now at this point, that's a problem, man. That's a problem.
Yeah, that's fair. All right, so let's move on.
Yeah, operational excellence.
David's second favorite pillar, I think.
I don't dislike
between the lines there.
Yeah, just because I have a theme song for it doesn't mean it's my favorite. Anyway,
I said second favorite. We all know reliability is your favorite.
That's true. It is my favorite. I cannot lie. I like big operational excellences, and I cannot lie. Can you please go to the next one?
I absolutely will.
Operational excellence is about ensuring that you intentionally address the operational concerns present at every point in an application's lifestyle, as opposed to getting them dropped on you or going, holy crap, are we supposed to operate this system? So.
Define system for us. What do we mean by system when you say our operational excellence of our system?
Oh man, that could be lots of things, right? That could be
loaded question. Throw it out there.
Yeah, it's right. A system could be anything. People could put it. I know what I think. Like I think more broadly when I think of system in this particular case. I do want to make note of something that Jeremy said in the chat before we move on, though, because it makes me so happy. Jeremy says that wouldn't the cost of storing your monitoring data also increase your cost? Yes, it would. Now, what is the cost of not knowing how well your system is running and whether it's going okay? I would suggest that that's a higher cost psychologically, financially. And in the future, you're basically driving with a blindfold on, and I think that's a bit of a problem.
Okay. The other thing is, if we go back to our thinking about durability of data, that's one that you can really start to think about how long do you need that for, and how long do you need the full refined data for? You may only want clickstream data for literally hours if you're processing it and then having that processed and rolled and reduced data go somewhere else for reporting. So we can think about the durability of that data, how granular and how long. The very granular data we might not need to keep very long. More coarse grain data, more roll up data that's at an operational level, we may want to keep longer, but we can think about how long that is, and we can get that into reports and process those and consume those, and then get rid of what we're not going to need to look back on.
Yeah, so these are cool cost op. This is really fun that we were talking about this in the other thing, but that's also a cost op question, right? For sure. Okay, what is operational excellence, and how do I get some? Let's go to the next one.
How do you get some? Use modern practices.
Yes, exactly. We're not, right. So modern architecture should be designed with modern operations practices and continuous integration in mind. Continuous integration is that thing where your build process allows for you to write some code and then make sure that code actually works in the context of what you've already written and what you've already done. So because, you're writing code, it's going to change stuff, and you want to make sure that you are in the place where you're not waiting months. You write some code and you go away for months, and then you hope that the version that you've been working on matches what everybody else has been working on in their own cave, right? And it's bad news. So that's kind of a software development practice more than I think an operations practice per se, but it's for sure part of that.
Well, I mean, this goes back to that super squishy question of what is a system? What are we operationalizing? And for me as a software engineer, that's always been top of mind in terms of the operations, how we get where we need to get, and what is our iterative process of delivering our software. So it's always been top of mind. Of course, you as a site reliability engineer, you almost think that's tangential. So it requires us all to build that.
I don't think it's tangential because, in many ways, site reliability engineering is about ensuring a reliable production environment. And guess how you make a reliable production environment? It's the stuff that feeds into it, right? And you have to be sort of aware that you can't take straw on one end of a pipeline and expect gold out. You don't poop out gold on the other end of a CI/CD pipeline. But if you don't have something in between that is trying to make sure that the stuff that you don't want in production gets addressed before it gets to production, that's where this practice comes in mind. And I don't think, again, it's required as part of operational tangential, but I don't immediately think about it as what you need to operate a system per se. But let's see what we do mean about that. Okay, so here's the thing that I think that probably is really key about this, which we've talked about before, is this notion that you really, really, really want to make. Oh, somebody's drawing on our screen. Who is that hooligan? Yeah, basically, you just find your pen or something. Is that what just happened?
I just saw monitoring and analytics again, and I thought I just really wanted to highlight it.
You did. You for sure did this. So yeah, so that's what we're trying to say here. We're trying to say, like, hey, it's absolutely crucial that you. Oh, okay. Great. It's absolutely crucial that you pay attention early on to stuff to make it so that in order to operate your system, you have to be able to understand it. You have to be able to observe it. You have to be able to understand what it's doing in production and even before it gets to production. And that's where you get into sort of monitoring analytics. And that's what we mean by building it into your stuff. Make it from the start able to understand what happened. Because when things go bluey, standing around scratching your head and sort of guessing at what happened and having no information and no data about it is just a bad place to be. And so this is trying to do that. So the other thing that we talked about before, and cool, I always like to look at this picture and figure out what it means, but it's cool. I get it.
You got at least it's JSON, not YAML. That makes me happy.
Yeah, the notion is that you want to automate as much of your workloads as possible because, stop feeding blood to machines, is what I would say. You want to make sure that you can get rid of as much of the toil as possible. And the key factor of getting rid of toil is automating stuff. Like if you go ahead and run a system and every Monday you spend 2 hours of your day, like doing all these processes, well, your system isn't any better off the next Monday. You're going to have to still do those processes then. If you can get those 2 hours down to pushing go, or not even pushing go, that's 2 hours you get back. I mean, this is pretty obvious stuff. But automate it. And there's some things that can be automated and some things that can't be automated, but automate where you can.
And really remember that force multiplier. So if you're automating your own tasks, you're getting some value out of it. If you're automating tasks that 4, 5, 50 people are doing, if you automate those, you're getting tremendous value, even if the N isn't very large, even if each individual optimization isn't very large. So many people are doing it so many times per day, it becomes huge.
Totally. Okay. Oh, I'm sorry. The other thing, can you go back one for a moment? Absolutely. And I'm noticing we're doing right here. We just talked about effort. We talked about reducing effort. But the other thing that automation also has the potential, but is not guaranteed to do, is reduce the errors in processes and et cetera. It's not just the effort that you're reducing, but you might also be reducing the chance of messing up something, leaving out a step, having your data be slightly wrong, putting the semicolon in the wrong place, lots of stuff like that. I have been in an environment where it really was, where somebody messed up the semicolon back in the days of their DNS name server, and it blew out the entire domain. It was really cool. Or otherwise known as not really cool.
No matter how good you are, if you have to do the same thing over and over and over again, some percentage of that time, 1 in 1,000, 1 in a million, some percentage of that time, you're going to do it slightly wrong.
Yeah, and this is not because human beings suck. It's just because but there's a reason why we write software, and we're not sitting around going 1001 to each other. We do it because the machines have the capability to handle this in a much more consistent manner, and there's value to that consistency. Okay, next item, please.
Testing. So I think a lot of people maybe are familiar with some of these. What I'd love to hear you talk about, David, is our chaos engineering.
Oh, okay. Yeah. So this testing that we're referring to here is kind of the sort of testing mostly that we're talking about, where you are testing for things you already know about. Right, where you're testing, like, is there an error? Did this code compile? Are my files consistent? Are they, do they pass some sort of schema test, etc.? So that's the stuff we know about, right? But there's a much more broad version of what testing can be in the world, including, dev test was what we're talking about. Round trip testing is where you're testing your whole system from beginning to end. Like, could my process, start here, and does it do everything that you'd expect, that the customer would expect it to do all the way to the end? Penetration testing is the security version of, like, can I get into it? Fault injection gets a little closer to chaos testing, where you're talking about intentionally injecting faults in your system to see how things behave. So if I were, for example, make my dependency fail, let's say my database layer fails in some ways or gets slower, what actually happens? So it's a nice way of sort of testing your system. Disaster recovery makes sense by itself. And chaos engineering is really fun, and I'm just paying attention to the time because I could go off for another hour and a half on that. But chaos engineering is this process of experimenting with your system to understand it better, to conduct real, honest-to-goodness scientific experiments where you're like, well, what if I were to do X? What if I were to make the latency go up between my database system and all my other systems? How would the thing behave? Stuff that you probably couldn't test some other way. And the thing that people talk about is, people like to think about doing it in production sometimes, because if you don't chaos test in production, the internet will do it for you. So just a thing to think about. Chaos testing is really cool. It's not just breaking stuff randomly. It's running these sort of scientific experiments to learn stuff in a way that you couldn't any other way. Like, by just imagining, like, what would happen and testing for that case. This will show you the things that you couldn't imagine. And for me, that's why it's so exciting. It may be a terrible name, but it's a really good practice. And I just want to say one last thing about this is, you can only really do this if you're at a certain level of engineering maturity. If you know that if I turn off my database, my app stops working, that's not a chaos testing, right? But if you know that I have built stuff in that is supposed to be fault tolerant, and I shut off my database, okay, that's a reasonable experiment. Did it work? Right? And what else broke because I shut off my database? So that's more close to chaos testing. So if you haven't checked it out, you should check it out. And in fact, Azure has this Chaos Studio thing, which if you haven't checked it out, you should check it out because it's really cool. Oh, we have one more pillar to do, and we have a really good 10 minutes or so to do it. So this is good. We are landing this right on time. Holy smokes. Okay.
And we're going to show performance in terms of how we deliver these slides. We're going to be very performant.
Okay, so performance doesn't mean just going fast, right? Like, there's lots of things that go into performance that you can measure. There's latency, we talked about before. We talked about throughput, which obviously Jason and I both care a lot about, and perceived responsiveness. Is it behaving the way responsiveness is both perceptual and it's objective, right? And you want to make it appear to be as responsive as possible. So there's lots of things about figuring out the performance of your system that really come into play here.
Yeah. So perceived responsiveness. Let me talk to this real quick.
Yeah.
If you think about your operating system, when you click an icon, it doesn't necessarily instantly bring up the application, right? However, what it hopefully will do is instantly make the icon react, or it may bring up your old hourglass. It does something, and that is because they engineered some perceived responsiveness into it. We know that clicking the icon is supposed to open an application, but we also know that can take 5 or 6 seconds. And so we engineer some other steps in there so that the user has this perception that the system is still responsive, even though it's not necessarily doing what they want yet. And so that's that perceived responsiveness. Think about giving the user some feedback. Don't worry, we're doing something as fast as you can, even if you can't do the end result instantly.
Yeah, and ironically, sometimes people put in things like that. Like, I know that I'm told that many of the travel sites that go boop, 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 we're trying to figure that out. Like, they already know the answer to the question. They're just going boop, 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 boop. So you realize that they're actually doing work there.
Yeah. That's a little bit of a different, that's a marketing thing.
Well, I guess so. Okay. But so performance efficiency in this case is where you're trying to match the resources you have to the application with its demand. And in order to do that, you have to do some sort of performance testing. You have to figure out sometimes that you're matching it properly. Sometimes you have to rewrite stuff. Maybe you're changing the indexes on your database. Like, there's lots of ways to get better efficiency with performance. And part of that is figuring out what you got.
And saying efficiency, the fact that we say efficiency, it's not only cost, but it should immediately bring to mind the fact that we're saying that, yes, this is part of a teeter-totter, a balancing act, a slider with cost. We can't just keep throwing money and resources at things necessarily.
Right, because you might be able to make a simple technical change, and congratulations, you're using a lot less resources, like that database stuff. Now, there are ways you can do that. There's ways of dealing with performance that also have to do with scaling, where you're either getting a bigger thing or you're deciding to shard your data, your operations into lots of small things. Scaling up only works so far because you're going to get as big a machine. Like at some point you tap out,
and you end up with that unused overhead as well. If you're just getting a giant machine, right, you end up with that unused overhead when you're at your peak times, or when you're at your non-peak times, I should say.
But sometimes things aren't written to scale out. And so sometimes, like it used to be classic that certain databases couldn't scale out; they can only scale up. Not as much true these days by any means, but you can't. It's not pixie dust. Your app has to be ready to scale out.
Absolutely.
Also, networking performance, right? Because you want to make sure that often as we build these little tiny things made out of microservices, you need to care a lot more about like what is the performance between that. So for example, if you're storing stuff in one region and you're running some application in another region, you might be crossing continents to write and to read from that database. Not so cool from a performance perspective.
Yeah, especially if you're making multiple round trips, if they're looking at each other constantly, going back
and
forth.
And like there's many ways to mess with storage, right? In terms of partitions and indexes, we were talking about this before, read performance, read speeds.
Even which database engine you're selecting is a big part of this consideration, because how you can index matters.
Yeah. We're in agreement. Sorry, I'm just violently agreeing with you. So yeah, so you have to think about this. Okay, next one. Also, there's some really cool tools like App Insights that can show you very clearly where your time is being spent. That can show you how much time how much speed, what the latency is between two different parts of your system. I love it dearly. If you haven't checked out the application map in the portal, I highly encourage you to think about that. Okay, we have a knowledge check. We should probably think about that in terms of timing, Jason. What do you want to do?
Okay. Well, we'll do one quick knowledge check here, and then we got five luxurious minutes left.
Okay, cool.
Which of the following is an example of scaling up? Vertical scaling. Is it updating your application to use a queuing service, adding more web servers into a web farm? Is it adding another virtual machine to your database cluster? Or is it updating a virtual machine to a larger size? Answer quickly, please.
Boop, 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 boop. Yeah, we probably won't do the other knowledge checks associated with this after this one. People can catch it in the Learn module for sure.
Yep.
Thank you, folks, for voting so quickly. I appreciate it.
Yes,
the answer is
updating a virtual machine to a larger size is an example of scaling up. And I'll just let you know. And as you might even imagine what the other question is, I know he said you could go look at the Learn module, but I'm gonna cheat.
Yeah. So scaling up is got to get a bigger boat.
Yeah. So it's the other side of yin and yang here. So scaling out then is adding our more servers. Yep.
Okay. So hey, it's a summary. So we have hoped that you have enjoyed the opportunity of sort of walking around and admiring the different pillars of the Azure Well-Architected Framework, and that we've given you sort of a different way to look at them and to think about them, but they're all kind of important as you're trying to figure out how to create an and keep your applications and your workloads in a well-architected state. And hopefully you get some sense of that there. If you want to get into this because you're as psyched as we are about this, you should definitely check out the Azure Well-Architected Framework guide in the Azure Architecture Center. It's kind of cool.
Tons of guidance, and beyond the guidance that's directly there, again, it's just an outstanding place for jumping off into the rest of the learning and documentation that Microsoft Learn provides.
Yeah, and I would also encourage you to check out the assessments. You can find them linked out of there, which allow you to have it ask you specific questions about your workload, and then it'll force you to ask the right questions. For me, that's super useful. The well-architected assessment stuff is really cool. But if you want to learn more, good news, there is the module that we're talking about. You can go check out the module. It won't be nearly as entertaining as we are, or depending on how you
or nearly as annoying.
Yeah, entirely plausible will be much less annoying, and so maybe it's the right thing to do that.
Speaking of less annoying, is our fantastic coworkers who will be doing the next in our Learn Live post Ignite series here. So be sure to check that out. That is all about training and evaluating AI models, ML models.
And who doesn't like those?
Torch.
So I guess now is roughly the time. I don't know the slide. Now is roughly the time where we thank everybody for their attention and their participation, for doing the stuff in the polls and asking us questions. You can find us on Twitter, as you can see, as just went scrolled by, and we dig it. So thank you so much for being part of this. It was really a blast to be here with you.
Yeah, what he said. Thanks, everyone.
Okay, DJ Laurent, take us out.